Welcome to today's mock. Today, let's do a question I like asking a lot because I think it's really fun. And I don't think I've asked it to you yet, but if I have, let me know.
Oh,
It is k nearest points to origin. Have you heard of that one?
uh, I don't know.
Okay.
I don't think so.
Okay, cool. So I think this would be a good question
K
to work through.
nearest points.
To origin.
Okay.
So the problem statement is pretty simple, actually. You are to write a function, and the function is to take in a list of
Okay.
points. Okay. And also taking a number k. So it takes in a list of points and a number k. It's an integer k. And you are to return
Okay. Okay.
the k closest points to the origin.
Okay. What is the origin in this case? Is it just 0, 0?
So yeah, so it would be 0.
Okay. So, like, wait, when you say list of points, you mean like coordinate points, right?
Yeah, it could be coordinate points. It could be
Okay.
whatever. I mean, it could be like, let's just say pairs.
Okay. Like, also integers, right?
Not necessarily.
Oh, how would they not be integers? Oh, like they could be like floats, like
Yeah, they
decimal
could be.
values.
Yeah.
Oh, okay. 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 Let me think. So, how would we compute the closest or like the distance between? Would it be like the what is it called? Like the Pythagorean distance when you like do like x squared plus y squared square root over that?
Yeah, that's right.
Is that
Yeah.
how you calculate?
Yeah, exactly. Yeah, yeah.
Okay. Okay. So I guess like what we can do is compute that distance for each of the points and then sort the distances and then
Okay.
return the first K points in that list.
Okay.
Okay. Um, okay, let me think of an example. So, like, let's say we're given 1, 1. Can we have duplicate points in our input?
Yeah, you can. Yep.
Okay. And in that case, do we want to return like the same point twice?
Not necessarily. I mean, for example, if you have two one ones and the k was one, you would just
Yeah.
return 1 1.
Okay. But like, what if the K was 2?
Well, then you would just return 1 1 and 1 1.
Okay. Okay. I see. Wait, but like what if we had more than 2 points? Like let's say there's 1, 2. Like do we want to return the K closest points that are unique or just the K closest points in
Just a k
general?
closest. Yeah, it doesn't need to be unique. Just a k closest. So in this case, it would still be the
Okay.
two one ones. Yeah.
Okay. So it'll be given as like a list of points.
Yeah.
Okay. So then I can compute the like Pythagorean distance. I don't know if that's what it's called, but for each of the points, so it would be like one, like square root 2.
Uh huh.
I'll just put 2 for now, and then 2, and then like square root 3, and then I can sort the list in ascending order. Well, in this case, it's already sorted, but
Mm-hmm.
if it wasn't sorted, then I would sort it, and then I would just return like the first 2 points of
Okay.
the list.
Okay. I like that general
Okay.
framework. Yeah. Yeah.
Okay. Okay. Did I start doing that?
Sure. Yeah. Let's get into it.
Okay. 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 Nearest points. We'll take in points and A. Okay. So I'm gonna have a list of distances, and then I'm going to say for each of the points, so like x, y, in points, then I want to compute your distance. Like, uh, Is this a function?
I think it's math dot square root.
I need to import math.
Yeah.
Okay. Okay. So, like, I need to store the distances in the list, but I also need to store the point that it maps to, because in the end we want to return the list of points.
Exactly.
So,
Yeah.
okay. I will append a tuple, maybe. It'll be like the distance and then the actual point that it maps to. Okay, and then after that, I want to sort this in ascending order. Um, and then I want to return the first k values.
Mm-hmm.
So, wait, let me think. How am I going to return it? I want to return it as a list of um, points, but right now it looks something like this. It's like a list
Yeah.
of tuples.
Yeah.
So I need to extract the points. I can just create a new list and be like Rai in range. Okay. And then the I'm gonna append that one. That makes sense.
Okay.
Does that make sense? So I'm gonna iterate through k times, and then I'm appending the second value of the tuple,
Mm-hmm.
which is the point, and then I'm gonna return it.
Okay. Yeah.
Okay.
Cool. Do you want to walk through the
Could
example you
we
had? Just
yeah.
yeah. Let's do a quick
Okay,
example.
sure. Okay, so um, I'm going to use this as my input, and then I'm going to be looping through each of the points, and then I'm going to be computing the distance, and then I'm going to append it to our list. So it'll be like square root 2, and then the 0.11, and then it'll be like the same for the next one, and then the same for this one. And then I'm going to sort it in ascending order, so it'll look the same after this.
Mm-hmm.
Okay. And then I'm going to build my result list, which will be like 1, 1, 1, 1, since k is equal to 2. And then I'm just going to return this as a list.
Mm-hmm. Okay. Yeah, looks good to me. Let's do a quick little time space analysis, please.
Okay. I think so. I think these loops run in O of n time, or like this one is O of n because I'm looping through all the points in the input.
Yeah.
And then this is O of k because I'm iterating k times. And then
Uh-huh.
the sorting will be n log n.
Mm-hmm.
So the time complexity will be O of n log n.
Yep.
And then space complexity will be O of n because I need to store n values in the distances array.
Yeah.
And then for the result array, that will be of size k.
Yeah. That makes sense. Okay. I think that's a pretty solid first pass. Let's go back again and
Okay.
look at how we can potentially improve this. Okay.
Mm-hmm.
So
Okay.
I think the first thing we might notice is that none of the time and space complexity it seems to depend on k. Okay. And that seems to
Yeah.
imply that we don't care about k when doing our operations, right? And that might be right, but in this case, I'm telling you, there might be some improvement we can have with regards to considering k, right? So that might
Mm-hmm.
mean we might not need to have all in distances in the array. We might not need to
Yeah.
sort all in
Yeah.
distances, right? Like if you think about it,
Right.
I mean, it is true that we'll need to use at least O of k space to to have the output, right? Like so that makes sense. So that's like a lower bound, right? But like, what can we improve on that front? So do you have any ideas, that we can think about there?
Yeah. Like we could use a heap
Hmm.
potentially to store at most k values in the heap.
Okay.
So like the top of the heap would be um like the maximum distance or like yeah, like the largest distance we've seen so far, and then as we're iterating through the points and computing their distances, if we get a smaller distance, then we can pop from the top of the heap and add that distance into the
Hmm.
heap.
Okay.
So we can limit the size of the heap to be k,
Yep. I like that.
and then yeah,
Okay, let's try to
okay,
implement that one. Yeah. So let's just implement a new function below that,
okay,
and then go from there.
okay. Okay, so I'm gonna have a heap. Mm, let me think how this works. So by default, like Python has min heaps. So
Hmm.
I'm gonna store the values as negative, I think, because I want to have the largest value at the top so I can pop from the top when I see a smaller value.
Yeah. Okay.
So, okay, I'm gonna have like this logic for computing like the distance. Or, oops. Okay, let me think. Um, so after I compute the distance, I need to check if there's space in my heap. So I want to be like, if the length of my heap is, if it's less than k, then I can just append it to my heap. So it'll be like heap cube, heap push, and then I need to pass in my heap and the distance. Okay. But if we have k elements, then I need to check if the current distance is smaller than the top of the heap. Right? So if distance is, wait, if distance is greater than heap at 0, then I want to pop from the heap. Pop. Okay. And then at the end, oh, wait, I need to append the distance, but also the point, because I need to still access the point.
Hmm.
Okay. And then I think I can just use the same logic for extracting the points into a list. Mm, yeah. Wait, actually, uh, it'll be like, oh, well, let me go through this to see if this makes sense. So if we use like the same example,
Hmm.
okay. So I'm computing the distance and then I'm checking if the heap is empty, or like I'm checking the length of the heap. So I'm gonna push on the first value, which will be -2 and 1, 1. And then I'm going to push on the next value. Okay. And then for the last point, we check the length of the heap and now it's equal to 2. So we want to check if the distance at the top, or if the distance we just computed, which would be 3, or like square root 3, is greater than Um, where 3 is greater than the distance at the top. Okay, it's not, which makes sense. So we don't do anything. But what if it was like 1, 0? Then it would be like then it would be like a smaller distance. So
Mm-hmm.
then we would pop from the heap, like we'd pop the top value, and then we would append like -1, 1, 0. Okay. I think that makes sense.
Yep.
Yeah.
Okay.
Um, Wait, one thing about this part is I don't know if this will like maintain the order of the heap. Or wait, does it matter if we like the order of the points that we return or no?
For now, it doesn't, but I'm glad you asked. Later than never.
Oh, oh, okay. Because I don't think this will like preserve any order because
That's
it's a
correct.
heap.
Yes, that's correct.
Yeah.
Okay.
Okay.
Time and space, please.
Okay. So the time would be I think wait. I think it's n log k because we're limiting the heap to size k,
Uh
but
huh.
we still have to go through n like values.
Yeah.
And then the space would be O of k because we're limiting the size to be k for
Yeah.
the heap.
Yeah. Okay.
Okay, okay.
Um, I mean, this is something which now I mean, you did bring up that we can now talk through, which is that it
Mm-hmm.
is true that the order is not preserved, and that's fine. However, we can still optimize the time and space, even like compared to the original solution, that is, um, while still considering order. So now I'll give you a new restriction, which
Oh,
is that we want to return the points in the order that they appear in the list, the original list. And
oh, okay.
as like a like an intermediate step, um, I also want to clarify a certain input. So this is one thing that you might not ask. I'll put at the bottom here. So like an example input would be something like let me think, and we'll do yeah. Okay, and then this will be k equals 2. So you could have 1, 1. Oh yeah, I'll do this. I think this works. K equals 1, -1, k equals 1. Right, so in this case, this is something you didn't clarify. But in this case, you want to
Mm-hmm.
return the one that comes earlier. Right? So this case is something which you want
Mm-hmm.
to return the ones earlier. And this is true even, for example, if you had, let's say, 0, 0, 0, 0, I can't type, and this is 2, you would still want to return, in this case, these two over here, because they appear earlier. So this is the earliest two that
Okay.
fit the criteria.
Yeah, that makes sense. Um, okay. In that case, I don't know if we can still use a heap because I don't think the heap respects the order. Or like, I guess I don't really know how that works. But I don't think that you can control the order after like when you're popping from the heap.
Mm-hmm.
So,
Okay. Yeah.
um,
Okay. So let's not
um,
consider like any time and space. Let's just think about correctness for now.
okay,
So let's back up on that front.
okay. Um, I guess like, hmm. I think like maybe I can sort of build off the first solution,
Mm-hmm.
computing like the distances between like the distances for each point. Um, but then like when I'm sorting the list, I need to somehow also sort by the index in which they appear.
Mm-hmm.
So let me think. So if I compute like the distance for each, so it would be 0, and then 0, 0, and 2. like maybe like as I'm computing the distances, I should also store like the index so that when I'm sorting,
Hmm.
it can also sort by the index, if that makes sense.
Yep, that does make
Like,
sense.
I don't
Yeah.
know, like maybe the second parameter should be the index, like its index in the input list.
Okay.
And then when you
Okay.
sort it, then mm, like when you sort it, if there was a tie, like, because there'd be a tie between these 2 points, right? Because they
Yes.
have, like, they produce like the same distance. But
Correct.
in this case, when a tie is encountered, then it will sort by the second parameter, which is the index. So it
Okay.
will sort, it will produce like this order.
Okay. Yeah. And
Yeah.
I might have missed
So
this
then
when
we
you
would
said it
return these
earlier.
two.
Sorry, but did you also say? Like, correct me if I'm wrong. But did you also say that because now
Mhm.
we're preserving the order, a heap won't do? Is that what you said?
Yeah.
Okay. Okay, that's fine. Yeah.
Okay.
Let's continue.
But like I'm not like completely sure. Like
That's
that's
fine.
just
Yeah.
what I
I
think.
know. I know. That's fine.
Okay. 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 Does this solution make sense to you though?
That makes sense. That makes sense. Let's code it up.
Okay. Okay. You can use some of my stuff from the last solution.
Yep, that's totally fine.
Okay. So I'm computing the distance for each point, and then in addition to the distance, I also need the index. Okay, let me see if I can get the index. Okay, and then I'm going to sort it, and then that should also sort by the index. And then I'm going to um, do the same thing I did here. In this case, the point will be at index 2. So, yeah. Okay. I think I think that's all I need to change.
Okay, so we're doing the same thing now, except we're sorting. We're sort of the sort here is sorting by the distance
The distance
and
first and then the index.
okay.
Yeah.
Okay. Um, are you confident in the syntax?
Let me think.
Just a test.
Yeah,
Okay.
looks right to me.
Okay. Sounds good. Okay. So notice here that we're so this is basically the same thing as your original solution, right? Oh, actually, no. Before we move on, let's do the time
Yeah.
space. Sorry, let's do time space before we move on. Yeah.
Oh, okay, okay. So the time complexity would be n log n
Mm-hmm.
because we're sorting and we're like iterating through all the points, and then the
Yeah.
space complexity would be O of n.
Mm-hmm. Okay. So this is the same as the original one, basically, right? Yeah. Exactly the same.
Yeah,
Um,
yeah,
okay.
yeah.
So when you thought about moving from the original solution to your first optimization, um, you thought, okay, we can use a heap, right? Can you explain to me why we
Hmm.
can't use a heap anymore? Like, what is the limitation there exactly?
Well, because we want to preserve the order of the points in the input list, but I
Okay.
don't think that the heap will preserve the order.
Does sorting preserve the order? Sorting doesn't preserve the order
Well,
either. Yet we're doing sorting. So what's the difference?
oh, wait, let me think. Sorting does not preserve the order.
Unless you do something about it, which it appears that you have.
Hmm. Yes. But like, yeah, like since I added the index, then I think that should be fine, right?
Yeah.
Uh-huh. So do like maybe we could add the index or the heap solution as well?
Mm-hmm.
Oh, actually?
Why not?
Okay. I don't know.
I mean, you're the interviewee. You tell me
Oh.
what's doable, what's not.
Oh,
I'm not lying to you, but I can't give you
I
everything.
guess so. Let me think. Okay, so then the index would be the second argument or like parameter, I think. Actually, let me use this example. Oops. Okay, so it's going to be like 0, 0, and then 0, 0, and then -2, 1, 1, 1, and then -2, 2, 1, 1. Okay. So like once I add these two, like the first 2 points in my heap, and then I try to add this one, but I see that this, like the distance we computed is the same as the one at the top of my heap.
Mm-hmm.
Um, and like also like the index is bigger, I guess. So then I would disregard this one. But yeah. So then when would I add it into the heap? I guess like if I see a distance that's smaller, then I would pop off the first value.
If you
So,
see one that's smaller,
or
y-
like
yeah,
when the distance is bigger because it's like negative. But
sure, yeah.
okay. Oh, like I guess like when I'm popping at the end, then like I need to like I'll have access to the index so I can sort it by index because we want
Yes.
to. Oh, but it's not just sorting by index. Wait, oh.
I mean, yeah,
So at
the
the
thing
end,
about
like,
it.
do we just want to sort by index, like not necessarily like the distances, right?
I mean, what do you mean by not like we still need the distance to be correct? Like they still need to be the k smallest or closest
Yeah,
elements.
yeah. But I mean like the distances don't have to be in ascending order for the points,
No,
right?
not necessarily. No, they don't have to be. Yeah,
Okay. Okay.
it's only for tiebreakers
So,
that you need to take that into account.
yeah. Yeah. Okay. Then um okay. So then at the end I want to sort by the index. Okay. How do I do that? Let me think. Hmm. Let me think about this. So this is
Okay.
what it'll look like at the end. And then I want to get this value first and this value after. But it'll pop from like if this one's at the top of the list, then this will get popped first. So, um, okay. I pop like both of the values maybe. So if I get like index and point. Okay, so now I have both the index and the point, and I want to append it to my result. And then I want to sort this by point. or by the
by
index.
index. Okay.
So, okay, so it'll be like result dot sort. And then since this is the first value in the tuple, it will sort by this value. And then I actually want to return just the points. So it'll be like return a list of points, or that work? So I'm like extracting the point for each end result. Yeah. Does that make sense?
Yep, that makes sense. So you're still sorting
Okay.
by the result after. Yeah.
Mm-hmm.
Okay.
But like since the heap is like of size k, then it will be like k log k for this
Yeah,
sort,
it would definitely
I
be a
think.
bit weird. But before we talk about complexity, let's just go through the example again. So I mean the one here still
Okay.
stands. So can you just walk me through what would happen in this case?
Okay. So I'm iterating through the points, computing their distance, and then like adding it to the heap. So the first value will get added to the heap, and then like the first two values will get added to the heap because that's when the size is less than k. And then for the last value, I'm comparing the distance computed to the top of the heap. So in this case, the distance computed is the same. So this won't get added to the heap. And then I'm building my result list. So this is what I have in the heap right now. And then I'm going to get the index and the point for each value and then append it to the result list. Or, yeah.
Okay.
Okay, so then it'll be like 0 and then 0. And then like 1, 1, 1, or square bracket, 1, 1.
One.
And
Yep.
then I'm going to sort it by the index and then return the points.
Okay. And so can you explain the mechanism at which the reason why we wouldn't in this case add the negative one to this list, to the heap in this case. So what is the mechanism that prevents us from doing that?
Um, this statement, like I'm checking if the distance that we computed is greater than the top of the heap. Oh, wait. Yeah. I added that because like the first value of the heap is the distance.
So also it's only if it's greater than the
Wait.
top of the it's only if it's like basically
Yeah.
worse. If it's worse than top of the heap, we wouldn't do that. Right?
Yes.
Okay.
Yes.
Yes.
Exactly.
Okay. No, that's correct. So I'm trying to get to the next point. So that's correct. What you said is correct. Um, so in this
Okay.
case, is it just for this input that be correct, or is that going to be true for all inputs? Like for example, what if the tiebreaker? Oh, sorry. What if there's like a duplicate point? Like let's say there's like a 1 1, like a situation like this again, but it's
Mm-hmm.
not the largest. It's not the highest distance, right? Is that going to be an issue?
Wait, what do you mean?
Um. So let me think. If we have an input, oops, I didn't even do that. What did I just do? What did I just do? Where am I? I hit my keyboard lost. Okay, here we are. I'm trying to think of an input that would. So let me think. If we have. Okay, let's say we have this as an example. Um,
Okay.
can we walk through this and see what happens?
Okay. So the first value will get added. The distance will be 2, 0, and then 1, 1. Okay. And then the second value will also get added. And then when we try to add this value, then like the distance will be 0.
Mm-hmm.
So, oh wait. Okay. So in this case, the distance is greater than the top of the heap. So I'm gonna pop from the top of the heap. This value will get popped. Wait, will it?
I mean, you can't guarantee which of those two gets popped because they have the same distance.
Oh yeah. Okay, but we would want this one to get
We
popped.
would want this one, yes, because this has a higher index, right?
Yeah.
But in a heap,
But
if you're not
for
comparing by
heaps,
that,
like, oh, oh yeah.
so it's pretty tricky.
Um, yeah, let me think. Hmm. I'm not really sure how that would work. Like maybe instead of storing these points as two values, they should be stored as one element in the heap
Hmm.
because they have the same distance. And then like inside this tuple, like instead it could be like the tuple would be like distance and then like a list of indices or something along with the points.
Okay.
Um, I don't really know where I'm going with this, but like at least in that case, then like you would only have one value for each distance, and
Right.
then um, like when you encounter a point that's closer, so like the 0, 0, then you can just delete one of the points within this distance. Like you would delete this index and delete this last point in the tuple.
Okay.
Does that make sense?
That makes sense. Okay, I'm happy to. I'm happy to. And do we do the time and space of this one? Do we do time and space of that one? Yeah, it's over here, right? Wait, this. I'm expecting this to be at the bottom of the screen. Yeah, because you modified the index. Okay, yeah, so I think we have. Do you have any changes you want to make to the time and space, taking into account the index, and not taking into account our new like discussion here? Just without this discussion, we assume there's going to be maybe some errors with that, but that's okay. But like without considering those, what do you think the new time and space would be? Like, would it change or not?
Like you mean for this solution?
Yeah,
Like the heap solution?
yeah.
No, I don't think so because like the size of the heap is still being limited to K.
Okay,
So I think that's
okay,
fine.
cool.
Okay.
Just write one more note down, and then we can do the post game interview. Okay, cool. So that's that. Pretty interesting question today, I think. And I think he had a pretty. I think he had a couple
Yeah.
couple points where he did things really quite faster than I expected, which is nice. So we got through a lot of follow ups today, which is always fun. Um, how do you
Yeah.
feel? How do you feel?
I think it was good.
Okay.
Maybe like last time because we also did a heap question.
Right.
So maybe I was like more familiar with this topic,
Okay.
but I think it went fine. Like I was able to get like the first solution with just sorting and then optimize it to use a heap.
Mhm. Mhm.
So I think
Yeah.
that was good.
Yeah. No, I think overall, I mean, similar in the sense that like you were pushing pretty quickly through the questions. That's always a good thing. And you did slow down a couple points to kind of question if things were like really, what you should assume, what's correct or not. So that's usually a good place to kind of slow down as well. So I think like overall on the meta level, that was
Mhm.
pretty well done. But of course, we can talk about some places to improve as well. Okay,
Okay,
so
okay.
the the first one is obviously that you need to ask more questions about the problem, um, right? Like
Okay.
tiebreaker, for example, is one that you just completely missed actually. Right? Like whenever, right? Like we should be thinking about this in terms of the list of questions you should automatically ask depending on the input type, right? Like you're returning
Mhm.
a sub list of the input. right? Like this is a situation
Yeah.
like this doesn't even matter what the question is. Just like you're returning a list that consists of elements from the input list. Then there's going to be a
Mhm.
tiebreaker if the list is smaller than the input list, right? There's going to be a tiebreaker. How are you going to resolve that, right? So I think again that's just a practice thing. You got to get used to asking these sort of questions because like this is where
Mhm.
Leetcode really kind of falls apart, which is like in Leetcode, there's basically no edge cases. And yeah, that is counterintuitive. A lot of people get caught in the edge cases, but compared to like real life, real problems, like the Leetcode ones are basically all happy cases. They're all straightforward. You immediately understand them. But that's not what a real interview might be looking for, and so you need to be prepared for that, right? So even when you're practicing
Okay.
online or with friends or whatnot, like you should always be thinking to yourself, what are all the possible questions that I would ask if this was a real interview, right? So you just
Okay.
got to keep that in
Yeah,
mind. That
makes
is like
sense.
a really big deal. And that would have
Okay.
saved you some grief. Now, to be honest though, if you were to ask that at the beginning, I still would have told you that doesn't matter. Return in any order, that's fine. But like at the end, that does matter because that's what the follow-ups are based off of, and that's where the complexity in the question really lies. Okay,
Hmm.
so
Yeah.
uh, excuse me. Yeah, so first couple stuff, yeah, first impression, that's all fine. Like nothing to say there. It's pretty like it's good that you implement it quickly, right? If it's a simple thing, nothing too much to worry about. Just do it quickly. I think that was very well done. One thing that I will say though is that, and this is depending on your comfort level, if you're having like if you feel like there's a lot of like if you feel like you're just breezing through the problem, you should be looking for like points to improve, right? Like where in the solution I'm writing out right now that can be improved, right? I'm using a sword. Can this be something else, right? So there is some room
Mhm.
to be to improve even on the naive solution based on your performance, right? So that's one thing to kind of keep in mind there. Um,
Okay. Yeah.
Follow-ups went pretty smoothly. One thing I will say, by the way, very fast intuition on max heap or the min heaps max heap situation. Um, I don't remember the question I asked you last time, but that might have helped. But like still, I think it's good that you were able to pull that out very quickly. That is something which is like if you don't get it, you can't get it. Like you have to just get that, right? Also good
Hmm.
for knowing that Python only has min heaps. I'm not sure if I was the one who told you that, but a lot of people get caught up on that. They'll say, "Hey, I'm assuming that this is a max heap or whatever," and it's like, no, that doesn't exist in Python. What would you do, right? So it's very good you caught onto that, and you know the trick about like just negating the number. So that's very good.
Hmm.
And
Yeah.
yeah, so that was good. And that's when you caught that the order is not preserved, which I told you it's fine to ignore. And then now we're talking about the real problem, which is that we're preserving the order, right? So this is the actual problem we're thinking of here.
Yeah.
Um, there's a couple ways to approach this sort of thing. The first thing you did, which is I think a good meta level decision, which is to back up and think about how we can, think about how we can reduce this new restriction to what we already know. And so that's where you start thinking about your original implementation with a sort. And that's totally a good place to start. That's totally fine. But like again, as you're implementing that, you really want to think about how this can be improved. And there's a couple reasons to say that. The first reason I say that is because I actually just told you that it can be improved, right? I told you that this could still be better than your naive solution. So
Hmm.
you should just
Yeah.
immediately be thinking about, okay, like what is about it? Like obviously you thought of heaps, but you thought heaps wouldn't work. So you should be thinking to yourself, okay, heaps not aren't working. Why aren't they working? It's because I can't get the index. I can't do this. I can't do that. So you should be thinking to yourself why it can or can't work, right? And by the way, that's a really good thing to like vocalize as well. Like talking about, hey, I'm
Right.
thinking about heaps right now. I don't think heaps can work because I can't the index. The index is important because of this and this. If a heap can't work, I'm thinking about the other one. So that's a really good thing to just kind of like voice out. Because in this case,
Okay. Yeah. Makes sense.
a heap does actually work, and it works in the same way that a sort would work. And I think I don't remember if it was you, but it was someone in the past like month or so that I was talking to, who was telling about sorting in Python. Now Python just completely spoils you with how automatic this sorting algorithm is, and that is because in Python for any sort, which is like for example, if you're sorting a list of collections, so a list of let's say a list of lists or a list of tuple, a list of anything that's iterable basically, it has a built-in tiebreaker. It's built in,
Hmm.
right?
Yeah.
So it sorts by
Yeah.
the first element, and those are the same. It sorts by the second one, and those are the same. If all two of those are the same, it sorts by the third one, right? So in Python, the sorting tiebreaking is actually built in, and that's something which I
Hmm.
believe you were trying to leverage here, but you just didn't quite get, just didn't quite get it right. Um,
Wait, are you
those
talking about the heap solution part? Like the
both
last part we were trying to do?
both for the heap and the list. So this is generic, but yes, this would be
Oh,
applicable
okay.
to everything. I'll come back to your last proposed solution, but right. So in
Okay.
general, I would suggest you study up on that. Like just read about how Python does sorting,
Okay.
how Python does tie breaking. That's something which is really going to save you time and effort. Now,
Okay.
there's also so I don't know your like coding background. I don't know like what language is your main language, but in most other languages, it's deceptive. It's both easier and harder. In other languages, usually you would be providing a comparator object, right? So you'd be providing a function essentially, which takes in two items that are in the heap or in the list, and it returns a value corresponding to which one should come first, which one should come last,
Oh,
right?
yeah. Like the
And
custom comparator that we did like a few sessions
yeah,
ago.
maybe it was you, yeah, but like
Yeah.
yeah, so that's available in Python as well, by the way. But
Oh, yeah.
um,
I forgot about that.
that's something which would solve the problem here because you write a
Hmm.
function which
Yeah.
compares the distance and then compares the index, right? And that would make it so that it's like a plug and play solution for your heap. You don't need to change anything at all, basically. Okay,
Hmm.
so that's something which you need
Yeah.
to just keep an eye out on because that's basically what the interviewer is looking for is like, okay, do you actually understand how sorting works? Do you understand the criteria I laid out? Right? Um, in Python, it's a bit more difficult because I don't think the heap takes in a custom comparator. You have to use the implicit one built into the sorting algorithms in Python. Um, and the other one, which is more advanced, but I would recommend you maybe take a look at as well, which is you can subclass objects with basically a comparable interface, and then the Python says, oh, this is an instance of comparable. Then I'll run your function instead of my default one. So that would have been another thing you could have done to get out of this pickle. So there's a couple ways to get out of it, basically. But yeah, none of them are too trivial if you don't
Okay.
understand how Python works in that regard.
Yeah.
And then the last thing I'll say is about your proposed solution. So this is, of course, the third option, which is obviously an option, is don't use the built-in things. You roll my own stuff, and I respect that because it's always fun. But let's talk about that. So yes, I think this would have worked, but you need to be very specific with the language. Okay, so the reason this wouldn't work based on what you said is that you cannot like when you anything over here when you add something to the heap, you can't know if that distance already exists. That's the issue, right?
Oh, yeah.
So the question is, okay, how
Yeah.
would you know if the distance already exists? So that's basically the question that you would have to figure out. Now, obviously, there's a couple ways around that. A really easy way around that is just by maintaining object references, right? So you can have like distances equals this, and have like zero object, or that's not zero, that's one, right? One object, right? And
Mhm.
then say
Yeah.
okay, and then you say, oh, if it doesn't exist, let's add it to this list. Let's add distance two, and I have my point. That's like I
Mhm.
can't think of something that's 4. Oh, that's distance two, right? So this is one way you can kind of do it to maintain a separate data structure on top of your heap, right?
Mhm.
But
Yeah.
that's that's really cumbersome, and that's not really elegant of a solution. But it would work. It would work, but you just
Mhm.
didn't think of that in time, right? So there's a couple ways to get out
Yeah.
of it, but I think this one just really comes down to missing some details about the sorting algorithm. So
Mhm.
that's sort of all the feedback. Any questions or comments on your side?
No, that made sense. So like the solution you were looking for was to implement like a custom comparator thing for hierarchy for the heap.
That would have been the most reasonable one. However, you could have also got me
Okay.
by just saying, okay, heap push, first object is a comparator, so distance and a negative index. You could have said, okay, I'm gonna, what do you call it? Oh, you have to enumerate it, so you'd be like index.
Oh yeah, I didn't do it yet. Yeah.
Right, right. But like I would have set it this as well, but you would have to explain
Okay.
to me why this is correct. And you would have to explain to me how the tie breaking works exactly. And this is something which I would ask, okay, well, if this is correct, why wouldn't you do it for this, or why wouldn't you do it for the previous solution? So I would say this would have also been accepted, but based on what you had shown me, that would have been a bit more like I would have asked more questions, if that makes sense.
Oh, okay. Yeah, yeah. That makes sense. That
But
makes
the
sense.
custom compared
Okay.
one would always be accepted because that's like a generic programming concept, right? That like I don't need to
Mhm.
doubt how
Yeah.
you know that. So yeah,
Yeah. Okay. Cool. Thank you.
cool.
Thank you for the feedback.
You're very welcome. You're very welcome. Anything else last minute? Otherwise, will you just end it here?
Okay. Yeah, we'll end it here. Thank
Okay.
you.
Thank
Talk to
you.
you later.
Yes,
Okay,
take care. Bye
bye.
bye.